All right, in problem 3, we have f is this differentiable function where f of 4 is equal to 3. And on the interval from 0 to 7, the graph of f prime, the derivative of f, is shown here. So it has a semicircle, and then it has, these two line segments. All right, so find f of 0 and f of 5. Okay, so one way to go about this is to set up an integral where we're basically going to have, I'm going to go from 4 to 5, the integral from 4 to 5 of f prime of x. Now, remember that the antiderivative of the derivative is just the original function, so this would be f of 5 minus f of 4. Now, since we can see the graph of f prime, we know that we can calculate that the integral from 4 to 5 is just the area of this triangle, which is just 1/2. Oops, 1/2. So then this integral is equal to 1/2. So 1/2 will then be equal to f of 5 minus f of 4. But we're already given f of 4. We're told that it's 3. So then from here we can find that f of 5 is just going to be 3.5. Next, we can find f of 0 by looking at the integral from 0 to 4. This, this region, has a semicircle, the radius of 2, so this will be negative 1/2 pi r squared, where the radius is 2, so this will just have an area of negative 2 pi. So then likewise, we can set up an integral from, let me just do it over here, integral from 0 to 4 of f prime. That's f of 4 minus f of 0. And we know that's going to be equal to negative 2 pi. And then we know that f of 4 is equal to 3. So then it's 3 minus f of 0 equals negative 2 pi. And then from here, we can calculate that if we add f of 0 and add 2 pi to the left, we can find that f of 0 is equal to 3 plus 2 pi. All right, now part B. Find the x-coordinates of all the points of inflection of the graph of f from 0 to 7. Justify your answer. Okay, so then remember the inflection point is basically where the graph changes from concave up to concave down. For that, we like to look at the second derivative. So here we're given a graph of the first derivative, so we want to look at the graph of the derivative of this graph. And one way to basically think about this is we just look at where the graph changes from increasing to decreasing or decreasing to increasing. So like the graph is decreasing up to here. So up to 2, then the graph increases after that. So we have an inflection point at 2, and it keeps on increasing up until 6. Then it goes from increasing to decreasing. Remember, it's where the first derivative changes from increasing to decreasing, or decreasing to increasing, positive and negative, or negative to positive. So then our inflection points would be at 2 and 6. Let me put part B over here. Let me actually write it up here so we don't use part B. And we can say since f prime changes signs here. All right, part C. Let g be the function defined by g of x equal to f of x minus x. On what intervals is g decreasing for 0 to 7, if any, show how we can find this out. Okay, so let's figure out what the derivative of g of x is, because if we can figure out the derivative, we basically just have to find where the derivative is negative, because when the derivative is negative, that tells you the graph is decreasing. When it's positive, that tells you the graph is increasing. So we want to look at the derivative of g of x, and that will be equal to g, we'll write it like g prime of x will be equal to f prime of x minus 1. And since we want to find where this is negative, we want to find where g prime of x is less than 0. In other words, we want to find where f prime of x minus 1 is less than 0. Or furthermore, we want to find where f prime of x is less than 1. Not 0, less than 1. That's a very interesting one. Okay, so then we have the graph of f prime, so we simply can just look to see where it gets larger than 1. So all along, up all the way to negative here, and it climbs up to 1 over here. After this point, it becomes, more than 1. It goes to 2, and then goes back to 1. So from the interval from 0 to 5, we can say that the graph of g of x is decreasing. All right, part D. I don't know why I put the B there. All right, so for the function g that we just defined in part C, find the absolute minimum value on the interval from 0 to 7. Justify your answer. Okay, so if you think about this, this is actually pretty simple. It's pretty intuitive. So going back to this graph, let's understand that g prime of x tells you the behavior of g of x. It tells you when it's increasing and when it's decreasing. Now, we found that g of x is decreasing essentially the entire interval from 0 to 5, so all the way until 5. After 5, it's increasing. So it's decreasing up to here, and it's increasing up to here. So if it's continuously decreasing, that means it's just from here to here, it's just getting smaller and smaller. So the value of g is getting smaller and smaller and smaller up to here. So you can think of this as the graph is going down, down, down up to x is 1. Then it starts going up. So the minimum is gonna occur at 5, because g prime or g of x is consistently decreasing all the way to 5. It doesn't show that it's increasing and then decreasing at any point before 5. It's decreasing the entire time until 5. Then after that, it's only increasing. So the minimum must occur at 5. Now, to find the value, we basically just have to evaluate this. We evaluate g of 5 is equal to f of 5 minus 5. So let's go ahead and calculate that. G of 5 equals f of 5 minus 5. We found that f of 5 earlier was 3.5. So 3.5 minus 5 will give us negative 1.5. And that's our solution.